Greetings, physical science students. Today I'm going to be talking to you about the classification of matter. Matter is anything that has mass and takes up space. So literally look around you. Anything that you can see or even the stuff that you can't see is matter. Matter on Earth exists in the ordinary forms that we are familiar with: gases, solids, and liquids. They come in an absolutely unending variety of forms. When we try to classify matter, we need to just ask ourselves some simple questions about it. First of all, can it be physically separated? So if the answer to that question is yes, then what we're dealing with is a mixture. Physical separation would be things like filtering or sifting or sorting. If the answer is no, then we're dealing with a pure substance. Pure substances cannot be physically separated. However, one category of pure substance, which is the compounds, they can be chemically separated, and we'll talk about that in a few minutes. Let's focus on mixtures for a bit. So when we think about mixtures, one of the questions we want to ask ourselves in order to define what kind of mixture is the composition uniform? Composition means the stuff that it's made up of, and uniform would be the same throughout. If the answer to that question is yes, that mixture is the same throughout, then you're dealing with a homogeneous mixture. Solutions are very familiar to us. Most of the beverages that you consume on a daily basis, with the exception of milk and milk products, but if it's something like coffee, and we're talking about just mainly just brewed coffee with no cream or anything mixed in, but if you're talking about coffee or Gatorade or Kool-Aid or anything like that, in all likelihood, you're dealing with a homogeneous mixture. If it's a homogeneous mixture, you cannot see the separate components. It looks the same all the way throughout that. If the composition is not uniform, then it's a heterogeneous mixture. Examples of heterogeneous mixtures that are familiar to you would be something like Chex Mix. If you look at a snack and it's got several different kinds of things in it, that's a great example of a heterogeneous mixture. Another example of a heterogeneous mixture would be like cookie dough. Chocolate chip cookie dough is a perfect example. You can see the big chocolate chips, you can see the batter, you can definitely make out the individual parts of that just by looking at it. On the pure substance end of things, that question, can it be chemically decomposed? If the answer is yes, then we're dealing with a compound. Compounds are forms of matter that consist of two or more elements chemically combined in a very unique ratio. Some examples of some compounds that you might be familiar with are things like water. Pure water is a compound. If it's pure water, now we got to be careful because tap water really isn't pure. That's a lot of stuff that's dissolved into that. So technically tap water would really be over in that homogeneous mixture side of things. But if we're dealing with pure distilled water that just has those molecules in it, that would be a compound. Another good example of a compound would be something that's in your medicine chest, hydrogen peroxide. Hydrogen peroxide is chemically very similar to water. However, it is one more oxygen, and that's also a compound that you might be familiar with. There are literally a ton of elements, and all you need to do is take a look at the periodic table. Elements have only one type of atom in them, and elements are unique in that aspect, and some that you might be familiar with are things like hydrogen, oxygen, silver, gold, copper, sodium, calcium. A sample of any of those substances would only have one kind of atom, and that would be the atom of that element. And then finally, we're going to elaborate a little bit on heterogeneous mixtures later. There are two specific types of heterogeneous mixtures that I'll be introducing to you, colloids and suspensions. Suspension is a really great word because if you think of something being suspended in air or in liquid, that means it's held up and that eventually it can fall down. And that's exactly what the nature of a suspension is. It's something like muddy water where eventually it will settle out. Colloids, on the other hand, have particles that are intermediate between solutions and suspensions, and so their particles don't settle. All right, so again, just a refresher, we're going to focus in on pure substances, the elements and the compounds. Remember that you're talking about things that have a very, very specific and defined composition. And so whether you're dealing with an element or a compound, the composition is always the same in that unique case. So some more examples. Elements like copper that you see on the left, aluminum foil, oxygen, gold, neon, platinum. The list is endless. Again, take a look at a periodic table and you'll get an idea of all the elements. Compounds, again, something very, very familiar to us. Remember that in a compound, the elements inside a compound are there in a fixed ratio. Compounds can be broken down into their respective elements, but still it's a pure substance because it has a defined fixed ratio, and chemical bonds hold the elements together. Compounds can't be separated by physical means, but they can be separated by chemical means. Common table salt, sodium chloride, is a compound that you're very familiar with. It looks, it looks like one thing, but if you could go to the very, very tiniest level and take a look at what makes it up, you'd find that sodium chloride is made up of tiny crystalline lattices of sodium atoms and sodium ions and chloride ions in a special kind of a bond. Okay, so one thing that we want to just touch on, and we'll talk more about it when we talk about compounds specifically, but you can have the same elements in two different compounds and their characteristics might be very different. Carbon monoxide, which is something you have probably heard of, is a very deadly, colorless, odorless gas that can sometimes be generated if our furnaces are not working properly. And carbon dioxide, on the other hand, is also odorless and colorless, but not deadly. We breathe out carbon dioxide all the time, and actually we rebreathe it very consistently as well. The difference between those two is a single oxygen, and yet they can be very, very different. Okay, going on with mixtures here, I mentioned the Chex Mix, a good example of a solution. In the middle picture there, you see some either sugar or salt being put into water and eventually would dissolve. We see sand like you'd see on a beach. That's a heterogeneous mixture. Remember, these are all physically combined. The substances are not chemically combined, and because they're not chemically combined, they can be physically separated. Okay, so properties of a mixture can vary because of the composition. It's not fixed. Heterogeneous mixtures and then homogeneous mixtures. This picture is a little bit out of place, but nonetheless, I'll talk about it. The G2 that you see there and the other Gatorade products, those are all homogeneous. They're uniform throughout. You can't distinguish all the different things in there, and yet if you read the label, you know that there's lots of stuff inside of there. The oil and water on the bottom, however, that is a heterogeneous mixture, and you can definitely see the individual portions and they don't remain mixed. Stainless steel is something you've seen a lot. That is actually a mixture. That's a homogeneous mixture. The iron, chromium, and nickel that's in stainless steel is not chemically combined, it is physically combined. Air is another great example of a mixture. Air has lots of things in it. So this helps us understand that mixtures can be gaseous, they can be solid, and they can be liquid. Some further examples of mixtures, solutions, just like the one I showed you in the earlier slide, colloids such as fog or gelatin, and then suspensions like muddy water that eventually would settle out. A lot of things that we encounter in our daily life are mixtures. I hope that helps. Fill out your assigned sheet and we'll talk to you on the next section.